Alright, so in the last session, you saw how we were able to get this CyberSyn dataset from Snowflake Marketplace very easily. We didn't have to create any objects like tables, views, and no ETL process. We just went to the marketplace, searched for this dataset, and then got it in, and then we can start using it immediately. So let's go through the rest of the steps. Once we got the data in, we will be exploring some more capabilities by running some SQL. So let's go back to our worksheet. We had created this virtual warehouse called analytics_wh to show that different personas can make use of different compute clusters for their activities. Earlier we were using compute_wh and now we are using analytics_wh. So let's see, I want to check the values inside this table. I'm running a select star, so you can do those kind of sequels. Next, what we are doing here by this command is we are checking the percent change in the stock price from previous day to the current day at the time of closing, and then 5-day moving average using the closing prices. So I'm using this partition by with 4 preceding and current rows over 5 rows to see the moving average over 5 days. And we run this query, it takes about 719 milliseconds. Now let's say I run this query again. There is another persona who comes and runs this query. What you will notice is that the query duration has been reduced significantly. So if you look at the last two queries, this query took 719 milliseconds when I ran it first time. Second time when I ran it, it took only 100 milliseconds. Why does that happen? If I look at the query profile, it tells me that it's doing something called as a query result reuse. So what Snowflake does is it has a caching called result cache. If we run the same query multiple times and the data has not changed, Snowflake just uses this result cache and returns the output immediately without having to actually use compute. So if you look at here in the cluster, this button is grayed out. That means this cluster is not running. But if I run this query, it just gives me the answer in less than 100 milliseconds. So the result cache is working and it's giving me the results immediately from the cache area. So imagine a scenario where multiple BI users are firing their queries from their reports, dashboards, and if this same exact query and underlying data hasn't changed, Snowflake can make use of result cache there. So that's a key capability which improves the performance significantly and reduces the compute. Now let's explore another capability called zero copy clone. Now in our production environments, we many times need to create copy of data for testing, development, QA. Now we end up creating these environments and replicating data from one to another. Now Snowflake has this unique ability called zero copy clone. Using this, you can just say clone of a base table or database or schema, and then Snowflake just copies the metadata over to create another duplicate object. So when I run this command, I'm creating this object called company metadata dev, which is exact replica of company underscore metadata. But it's not physical copy. It's only using metadata to create a copy, as a result of which the storage space does not get doubled. So if I open this database and go inside that, you will find I have now two tables and I can operate on both of them independently without affecting another one. I can delete this table, continue to work on this one, or vice versa, because after creation they become two separate objects. So you can very quickly create clone copies like this without having to wait for physical full copy or without paying for the storage for the duplicate copy. You can start doing your QA development on this replica or zero copy clone. Right, so that's how you can quickly create these clones. We talked about result cache. You can of course join two data sets, like the JSON dataset which is in one table and joining with the other dataset called sec filing attributes. So this is the join query. I just copied over and then I'm running it. So just goes on to show that Snowflake can do all of these traditional table joins and perform them quite efficiently. All right. Now let's look at another key capability called time travel. Now, as an administrator, we operate on the data quite a bit. Sometimes we may end up deleting data by mistake or dropping a table accidentally. So I have dropped this table now, and of course if I try to select from this table, I'm gonna get an error that this object does not exist. Now normally you would have to go back to your backup, restore it, wait for quite some time, and all the users will be frustrated in the meanwhile because their queries, reports are not gonna run. In Snowflake, it's very easy to recover this data. You can just say undrop command and the table is back from the dead, and you are able to now see the data inside that. Yeah. So this is dropping and undropping, but time travel can go beyond that as well. In case I have done a wrong update, like let's look at this example as well. And what I'm gonna do is I'm gonna update this table and setting this company name to oops. So it updates 28 rows, and when I run this command now, I'm just gonna expand this a bit so you can see that now the company name has become oops. Again, in normal scenario, I would have to go back to the backup and restore it. In Snowflake, what I can do is go back to the point in time before I ran this query. And how do we do that? We need either the time offset or we need the query ID. So here I'm finding that query ID which was generated when we ran this update statement. So Snowflake has a very good audit trail. So for example, for the queries, it has a table called query history by session, and we looked at the last command which had update in it. So, and that value goes into a variable called query ID because we have set the query ID equal to that value, right? Now what I can do is I can go back to the point before this query was fired and do a select star from my table. So here we are creating another table with the same name. So you're actually replacing the same table, but then going back before that statement of update was fired. If I now do a select star, you'll notice that now the company name is coming properly. So you can very quickly go back to the state which was desired because Snowflake maintains all these versions of tables utilizing the immutable object store behind the scenes.